Okay, welcome back everybody to another edition of this series called Working in the New Normal. And we're probably wondering at this point when this new normal is going to happen. Don't know, but we're looking forward to it, I'm sure. Like when can I actually go get a haircut? Or do I have to actually cut my own hair or have my wife cut my hair? That's a question that's looming currently in my mind. But I wanted to address an important subject that I think will have a lot of importance, applicability in the new normal, and that has to do with the idea of modeling. Now, I don't know if you noticed this, but with the coronavirus, they're using models a lot, and they're reporting on the results of these models to project, to project the growth of infections and so on. They actually have computer models doing this. And at a quite detailed level. So you can look at almost any town or city in the US, not to mention the state or the world, and not only see the history, but see what the models predict. And those models are continually updated as people do a better job of isolating. Then those trend lines and those models reflect those changes, which is great. But we're getting used to using models in a lot of areas of our life. For example, in the last couple of years, I spent quite a lot of time in Florida, and we monitored the progress of hurricanes and these weather models, and in forecasting the path of these hurricanes or projected hurricanes was a big deal, and something that we looked at a lot. So I'm sure you're familiar with that. Other kinds of models. My wife is an architect, so using these CAD systems designed for architects, you can design the house, but then you can model solar access, you can model shade during different times of the year, et cetera, et cetera. All kinds of amazing things can be modeled before you actually build the house, which is tremendously helpful. And then, like, turning back the clock a little bit, we go back to models like just something as simple as a wind tunnel, which I think the Wright brothers worked on. So before you build the airplane, wouldn't it be a good idea to test it, right, in a cheap environment so that you can make corrections and adjustments before you actually invest in building the whole thing? So you see where I'm going with this. Clearly, where I'm going with this is in the world of Lean. Why would you want to design a value stream and then build it physically, make all that investment, and then have to fix it later? So in fact, Jim Womack with the Lean Enterprise Institute has called Kaizen, in many cases, a form of rework. So why wasn't it done right the first time is the question. Well, one of the reasons is it's complicated. To design a value stream, and it's hard to know how that value stream is going to actually work, how it's going to perform in the future. That's easy to understand. Now, the more mixed model that you get, the more different products and the more different processes that you're trying to link together, combine, then the more difficult it is to really know how this is going to perform in the real world before you build it. Without building some kind of model, some electronic model. So when I say model, I'm not talking about cardboard cutouts. Those can be useful, right? Little paper dolls. Those could be kind of fun, but that's not what I'm talking about. I'm talking about what's technically referred to as discrete event simulation modeling. That's computer modeling that actually slices time into a bunch of little chunks and emulates the movement of entities or products through a series of resources or processes, and allows you to kind of see what would happen in various scenarios. So simulation doesn't necessarily tell you what the optimum design is going to be, but it will show you what might happen if you did this or you did that. So it allows you, in other words, to run experiments very quickly. So why wouldn't we want to do this? This is something we'd want to do, correct? We don't want Kaizen, actually. We'd like to do it right the first time and then not have to Kaizen it forever or make especially major changes. That's the worst time. The absolute worst time to have to do Kaizen is after you've designed the line. So before you do that, before you actually implement the line, that's the right time to do Kaizen. That's the cheapest time where you can actually make changes. So simulation tools for manufacturing or for value streams does exist. It's not even new, but why isn't it more widespread? Well, this has been a kind of an obsession of my own for quite a few decades now, because I knew that these tools actually existed. Why weren't they just in common usage? Well, they are used, to a large extent, and maybe some of you watching this saying, "What do you mean? We use these all the time." But actually, if you did a survey of lean professionals, lean specialists, you'd find that really a minority of those folks are actually using simulation. And there's even a school of thought that says, hey, simulation modeling is unlean. What we should do is go to the Gemba, and work with people and improve processes that way. Well, that's all well and good, but really what we want to achieve is a design, just like building a house. We want to design it properly up front before you actually make that investment. So then back to my question, why isn't this more widespread? Why doesn't everyone do this? In other words, well, there are a couple reasons. One is, and I don't think this is a major showstopper, but the software exists, but it's very expensive. So it's hard to just buy, a $5,000 or $10,000 piece of software to play with, to see if you like it or not, et cetera. So that shouldn't be a hurdle for bigger companies, but that is a slight roadblock, that this software is quite expensive. And it needs to be, actually. It needs to be, because this is not a high volume thing. Simulation software is not like buying a copy of Microsoft Word where everyone has one. It's a specialized piece of software. So you'd expect to have to pay more if you expect to have support and an ongoing R&D effort and making it better over time. So that's one challenge. But I think the biggest challenge, the biggest roadblock to widespread implementation is that, at least up to now, it's been complicated. It's complex. And so to really get good at simulation modeling, as I learned by working with a simulation modeling company for several years, to really get good at this, you really have to dedicate yourself to it. You can't expect to get really good unless you're a super genius. If you are, congratulations. But if you're just a normal person, to get good at simulation modeling, you really have to put in the time, right? The 10,000 hours or the lots of time to get really good at it. So it doesn't matter how much the software companies can tell you that it's really user-friendly and really easy to use. These tools are complex, especially when you're trying to emulate or model reality in a very precise way. Because once you get down beyond just the basic built-in tools of this software, you're going to probably have to do some kind of coding, some kind of programming. So to get good at this kind of stuff requires you to invest the time, just like anything else, right? To get good at playing guitar, maybe you're a guitar genius. I haven't seen too many of those, but even if you're Eric Clapton, you've spent thousands and thousands and thousands of hours practicing, right? So that's a hurdle. So it's complex. The third hurdle is that the software that's available now is intentionally multi-purpose or general. But in the lean world, most of what we're doing is based on kind of sequential flow, value stream. That's why we call it a stream, right? Because it's flowing from one process to another. So our needs within the world of lean or flow manufacturing is a little bit more specific. But these tools are not designed to do that. Now, can they support flow? Of course they can. Of course they can. But they're not designed specifically to do that. So it just makes it harder. So there we go. So the lesson here is that if we have some time now, if we have a little bit of a slowdown during this preparation for the new normal, it might be a good time to actually invest some learning in simulation modeling, because our vision of the future anyway is that every substantial Kaizen project or line design project should have a model, right? Modeling should be part of it. if you want to get to the point of really having a tested, robust design that can handle changes in mix and changes in volume without choking and dying, you need to create a model, because you can't understand this other than a very simple design. You can't understand how it's going to perform in your head. It doesn't matter how experienced you are, you can't really know how your design is going to be performing without modeling it. So if you look over on the right side, there's some links we've added there for some information. But we've been developing a tool, simulation modeling tool, to hopefully address some of these challenges: the cost, the complexity, and the kind of the specialized nature of what we do. We tried to address all three of those things. So I would suggest, if you have a minute or two, to check that out. But with that, we'll leave you, and we'll see you next time. Bye-bye.